There is a hidden air filter on your Subaru that almost nobody checks. Not the engine air filter. Every owner knows about that one. Not the cabin air filter. Most owners have heard of that one too, even if they forget to change it. A third filter. Hidden in a location most owners have never looked at. Not mentioned in most maintenance schedules. Not checked during most routine services. And when it gets clogged, it causes a specific set of symptoms that get misdiagnosed repeatedly as much more expensive problems. Rough idle that comes and goes. Hesitation on initial acceleration. Slightly elevated fuel consumption. A subtle but persistent lack of smoothness that wasn't there when the car was newer. Owners spend hundreds or thousands chasing these symptoms. New spark plugs, throttle body cleaning, mass airflow sensor replacement, fuel injector service. All legitimate maintenance items, all capable of causing these symptoms, and all completely ineffective when the actual cause is this hidden choked filter that nobody bothered to check. I've seen this specific oversight cause a $0 fix to become a $600 misdiagnosis. I've seen mechanics replace sensors and clean injectors while the actual culprit sat untouched in its hidden location, quietly starving the engine of what it needs. The filter I'm talking about is the air oil separator filter, also called the PCV filter or crankcase ventilation filter. And on modern Subaru engines, it's a critical component that belongs on your maintenance schedule right alongside oil changes and tire rotations. Today, I'm telling you exactly where it is, what it does, what happens when it fails, how to check it, and how to replace it yourself in under 30 minutes for less than $30. Let's get into it. What this filter is and what it does. Before the location and procedure, you need to understand why this component exists and why its condition matters so much to engine performance and longevity. The crankcase ventilation system. Every internal combustion engine produces blow-by gases. These are combustion gases that escape past the piston rings during the power stroke and accumulate in the crankcase below the pistons. These gases contain unburned fuel vapors, water vapor, combustion byproducts, and fine oil mist from the moving components below. Left in the crankcase, these gases create pressure that forces oil past seals and gaskets. They contaminate the oil, accelerating degradation and increasing wear. They create sludge deposits that restrict oil passages. The solution is the positive crankcase ventilation system. The PCV system routes these blow-by gases out of the crankcase and back into the intake manifold where they're burned during normal combustion rather than released into the atmosphere or left to contaminate the crankcase. The oil separation problem. Here's the issue. Those crankcase gases carry significant amounts of oil mist. If that oil mist flows directly into the intake manifold and gets burned, you lose oil. More importantly, on direct injection engines like the FB25 and FA20, that oil mist bakes onto the intake valves as carbon deposits, causing the exact carbon buildup problem we've discussed in other videos. The air oil separator sits in the PCV path specifically to solve this problem. It's a chamber with baffles, mesh screens, or a filter element that causes the oil mist to coalesce into droplets, separate from the gas, and drain back into the crankcase through a drain passage. Only the cleaned gas continues to the intake manifold. The filter element. In modern Subaru PCV systems, particularly on 2012 and newer FB series engines and all FA series engines, there is a replaceable filter element within the air oil separator housing. This element provides the surface area on which oil droplets coalesce and separate. Over time, this filter element accumulates the very oil residue it's designed to capture. It also accumulates carbon particles, combustion byproducts, and the fine particulate matter that passes through the piston rings. As the filter element clogs, the PCV system loses its ability to draw adequate vacuum from the crankcase. Pressure builds. And here is where the expensive-seeming symptoms begin. What happens when this filter clogs? Understanding the failure progression helps you recognize when this filter is your problem, rather than a sensor, an injector, or a mechanical issue. Early stage clogging, 30 to 50% blocked. The PCV system is still functioning but with reduced efficiency. Crankcase pressure is slightly elevated above normal. Symptoms at this stage are subtle and easily dismissed. Idle quality that's 90% of what it was when new, not obviously rough but not quite smooth either. Fractionally reduced fuel economy, maybe 0.5 to 1 miles per gallon. Easy to attribute to fuel price variation or seasonal changes. A very slight hesitation on initial acceleration from a cold start that goes away once the engine warms up. Most owners don't notice these symptoms or attribute them to normal aging. Moderate stage clogging, 50 to 75% blocked. Crankcase pressure is now meaningfully elevated. The system is pulling excess oil vapor into the intake because it can't separate efficiently. Symptoms become noticeable. Rough idle that comes and goes, sometimes smooth, sometimes lumpy. Often worse when the engine is cold and the PCV system is working hardest. Visible oil residue inside the intake tube if you remove it and inspect. On a healthy engine with a clean separator, the inside of the intake tube is relatively clean and dry. Very slight blue tint to exhaust under light load, from oil vapor reaching the combustion chamber. Oil consumption slightly higher than normal, a quart every 2,500 miles instead of the previous 3,500. At this stage, misdiagnosis becomes expensive. The rough idle triggers a MAF sensor check. The oil consumption triggers a ring wear concern. The hesitation triggers throttle body cleaning. None of these address the actual problem. Severe stage clogging, 75 to 100% blocked. The PCV system is effectively non-functional. Crankcase pressure has built to the point where it's forcing oil past gaskets and seals. Symptoms are now impossible to ignore. Oil leaks appearing from multiple locations simultaneously. Valve cover gasket, front crank seal, rear main seal, dipstick tube. Check engine light with codes P0171 or P0174. System too lean, caused by the vacuum leak created by excessive crankcase pressure. Significant oil consumption, a quart every 1,000 to 1,500 miles. Rough idle and hesitation now constant rather than intermittent. Possible blue smoke at startup from oil accumulation in the intake. At this stage, owners are getting quoted for valve cover gasket replacement, rear main seal replacement, and short block replacement for oil consumption. The actual fix is a $15 to $25 filter element and 30 minutes of labor. Location by model. The air oil separator filter location varies by engine family. Here's exactly where to find it on each major Subaru platform: FB25 and FB20 engines, 2012, to present Forester, Impreza, Crosstrek, Outback, 2.5 liters and 2.0 liters. The air oil separator on FB series engines is integrated into the valve cover on the driver's side, left bank when viewed from the front. There is no separate housing to locate. Instead, there is a port on the valve cover with a hose connection leading to the intake manifold. The separator, baffle, and filter element are internal to the valve cover itself. On these engines, the serviceable component is the entire valve cover assembly if the integrated separator is damaged, but many FB series engines have an accessible clean-out port that allows the separator passages to be cleaned with solvent. Access. Remove the engine cover if equipped, then locate the large hose running from the valve cover to the intake manifold. This is the PCV hose. The separator is at the valve cover end of this hose. FA20DIT and FA24DIT engines, WRX, Ascent, Turbo Outback, and Legacy. Turbocharged FA series engines have a more sophisticated air oil separator system due to the higher blow-by volumes produced under boost. On the WRX specifically, the air oil separator is a separate component located on the passenger side of the engine bay, with hoses connecting it to both the valve cover and the intake system. It is roughly the size of a large coffee mug, plastic construction, with 2 or 3 hose connections. The filter element inside this housing is replaceable without replacing the housing. The housing is typically secured with 2 to 4 bolts and can be removed for inspection and element replacement in approximately 30 minutes. EJ25 engines, older Outback, Legacy, Forester, Impreza through 2014 on some models. The EJ25 uses a simpler PCV valve rather than an integrated separator with a filter element. The serviceable component is the PCV valve itself, located on the valve cover and connected by a hose to the intake manifold. On EJ25 engines, the PCV valve is a simple spring-loaded check valve that costs $8 to $15 and should be replaced every 30,000 to 40,000 miles. It either works or it doesn't. A quick test: remove it and shake it. A working PCV valve rattles, a seized one doesn't. How to inspect the system. Here's how to inspect the air oil separator system on your Subaru without removing anything yet. Inspection. Step 1. The intake tube check. Locate the large rubber intake tube running from the air filter housing to the throttle body. Loosen the clamp at the throttle body end and rotate the tube so you can see inside. What you should see: a relatively clean, dry interior with at most a very light film of moisture. What a clogged separator shows: obvious oily residue coating the inside of the tube, sometimes with visible oil pooling at the lowest point. Oily intake tube on an engine with acceptable oil consumption, less than 1 quart per 3,000 miles, strongly suggests a separator that's passing too much oil vapor. Inspection. Step 2. The oil filler. Cap check. Remove the oil filler cap with the engine idling at operating temperature. Place your palm loosely over the opening. You should feel slight suction pulling your hand downward toward the opening. What this means: the PCV system is maintaining negative pressure, vacuum, in the crankcase, which is correct. If you feel pressure pushing your hand upward, the crankcase is pressurized, indicating a severely clogged separator or failed PCV valve. This is the condition that forces oil past seals and gaskets. If you feel nothing at all, the PCV system may be completely blocked or disconnected. Inspection. Step 3. The hose inspection. Trace the PCV hose from the valve cover to the intake manifold. Feel each section of the hose. It should be pliable and smooth. Stiff, brittle, or cracked sections need replacement. Disconnect the hose at both ends and look through it. A clean hose shows clean bore with slight moisture. A restricted hose shows oily, dark residue inside, sometimes partially blocking the bore. Before we get to the replacement procedure, this hidden filter is one of several maintenance items on modern Subarus that fall between the cracks of standard service schedules. I've documented every one of them, with correct service intervals for each engine family, in the 500,000 mile car maintenance blueprint. Link in the description. How to clean or replace the system. For FB series engines, the FB25 and FB20 separator passages can often be cleaned without parts replacement if caught before severe clogging. Materials needed: throttle body cleaner or carburetor cleaner spray, clean rags, compressed air if available. Disconnect the PCV hose at both the valve cover end and the intake manifold end. Spray cleaner through the hose in both directions until it runs clear. Spray cleaner into the valve cover port and allow it to soak for 5 minutes. If accessible, use a long flexible brush, pipe cleaner or bottle brush to clear the separator passage inside the valve cover. Blow compressed air through if available, or allow to air dry for 15 minutes before reconnecting. If cleaning doesn't restore correct function, palm test still shows pressure rather than vacuum, the valve cover assembly may need replacement on severely clogged FB engines. Cost: $150 to $300 for the part, $200 to $400 for installation. For FA series turbocharged engines, The separate air oil separator housing on turbo models is the most straightforward replacement. Materials needed: replacement filter element, IAG Performance or OEM Subaru, $15 to $45, 10mm socket, new gasket if supplied with the element. With the engine cold, locate the separator housing on the passenger side of the engine bay. Photograph the hose routing before disconnecting anything. Disconnect all hoses from the housing, noting which hose connects to which port. Remove the housing mounting bolts, typically 10mm, 2 to 4 bolts. Open the housing. The filter element is inside, typically a foam or mesh cylinder or disc. Note the condition of the element. Brown to black saturation with oil and carbon is normal for high mileage. Complete collapse or disintegration of the element material indicates severe neglect. Install the new element, ensuring correct orientation. Reinstall the housing with new gasket if applicable. Reconnect all hoses to their original port. Start the engine and verify with the palm test that the crankcase is now under slight vacuum. For EJ25 engines, simply replace the PCV valve. Remove it from the valve cover, take it to any auto parts store to match the size, and install the new one. Torque key, hand tight plus a quarter turn. Do not over-tighten in the aluminum valve cover. Replace every 30,000 to 40,000 miles preventively. Service intervals. Here is the correct service interval for each Subaru engine family, based on real-world failure data, rather than conservative manufacturer guidance. FB25 and FB20 naturally aspirated. Inspect and clean separator passages at every 30,000 miles. Replace valve cover if passages are uncleanable. FA20DIT WRX. Replace the air oil separator filter element at every 30,000 miles. Turbo blow-by volumes accelerate filter loading significantly compared to naturally aspirated engines. FA24D IT Ascent Turbo Outback Turbo Legacy. Replace at every 30,000 miles. Same reasoning as WRX. EJ25. Replace PCV valve at every 30,000 to 40,000 miles. If you do most of your driving as short trips, under 10 miles each trip, reduce these intervals by 30%. Short trip driving increases blow-by volume and accelerates filter loading because the engine never fully purges moisture and condensation from the crankcase. The DIY cost versus shop cost. Here's the financial picture for addressing this maintenance item. DIY cost: FA Series air oil separator element, $15 to $45 depending on brand. Time, 30 minutes. Total, $15 to $45. EJ25 PCV valve, $8 to $15. Time, 10 minutes. Total, $8 to $15. FB Series cleaning, solvent cost approximately $8. Time, 30 minutes. Total, $8. Shop cost. Most shops charge $80 to $150 in labor for this service plus parts markup. Total at shop, $120 to $250. Cost of not doing this: misdiagnosis and unnecessary repairs, chasing rough idle and oil consumption, $300 to $800. Valve cover, gasket replacement for pressure-induced leaks, $400 to $700. Rear main seal replacement for pressure-induced leaks, $500 to $900. Catalytic converter damage from oil burning, $1,200 to $2,000. 30 minutes and $25 versus potentially thousands in downstream repairs. The return on investment is one of the highest in all of Subaru maintenance. The bottom line: there is a hidden air filter on your Subaru that almost nobody checks. The air oil separator filter inside the PCV crankcase ventilation system. When it clogs, it causes rough idle and hesitation that gets misdiagnosed as sensor or injector problems. Oil leaks from multiple locations due to excessive crankcase pressure. elevated oil consumption from oil vapor bypassing the separator into the intake, carbon buildup on intake valves from unfiltered oil mist. Check engine lights for lean codes caused by vacuum disruption. Where to find it? FB series engines, integrated in the valve cover, access via PCV hose port. FA series turbocharged engine, separate housing on the passenger side of the engine bay. EJ25 engines, the PCV valve on the valve cover. How often to service it? Every 30,000 miles on all engine family. Every 20,000 miles for short trip drivers and turbocharged models. What it costs to fix? $8 to $45 in parts and 10 to 30 minutes of your time. What it costs to ignore? Hundreds to thousands in misdiagnosed repairs and downstream damage. Check this filter today. If you don't know when it was last serviced, assume it hasn't been and address it at your next oil change. And if you want the complete list of maintenance items that fall between the cracks of standard service schedules, all documented with correct intervals for every Subaru engine family, check out the 500,000 mile car maintenance blueprint in the description. If you found this video helpful, be sure to watch this next video as we're sharing insider tips to help you cut repair costs and keep your car running like new.